know how some of these lectures go, to pick up any questions that you have regarding these things. Cloud computing and data centers it's interesting, but we do not go massively into it yet. We will have further discussions later on in some of the contents where we cover items. Please feel free, as I say, more questions, the more fun it is for all of us. Okay, so today's lecture, we're basically going to be covering the introduction. So we're going to define what cloud computing actually is. We're going to understand the advantages in the cloud computer models. And we're basically going to talk about identifying current cloud computer models, their benefits, and how we can best use those items. So let's have an introduction to cloud computing. We all probably use cloud computing in one form or another at the moment. So cloud computing generally is defined as the delivery of computing resources, remember resources, over the internet. Now that's a big, fluffy, for want of a better word, big cloudy type of description, okay? Really what we're doing is we're providing people access to compute, which is basically the processing of data and programs and items such as servers, and also storing stuff. So stores such as file stores, databases, buckets, as well as that. We basically go into how those are. A lot of this is referred to as infrastructure. Okay, so we will call this infrastructure as code and code themselves. A lot of cloud computing, or majority of cloud computing services, are basically given as a pay-as-you-go subscription. So you don't have to purchase items. It is a cost-effective solution. Depending on who you chat to, there's pros and cons about whether or not it is an operational expenditure and whether or not it is a capital expenditure, as to how you tend to balance that, whether or not cloud computing is cost efficient. It is a very good idea for small companies scaling up, because they do not have the massive capital to go out and supply and purchase lots of big frame servers to do what they want, but they know full well they can pay for it on a subscription service because they've got money coming in, but not got a massive budget to simply spend straight away. So the advantages of cloud computing, it is on demand. Okay, if I want to spin up something in the cloud computing world, yes, I will simply go and pay someone and they will spin it up for me. I don't have to make a plan for it. I don't have to plan months and months in advance. I can simply go, oh, today I want some more services. Let me go to a cloud computing service and get those services. It has broad network access. Doesn't really matter where I am, from home, from work, out on a boat somewhere, connecting via a mobile telephone or something like that. I can access these particular items wherever I happen to be. It has what's known as resource pooling, and we'll go a little bit more into resource pooling later in terms of why that is great for cloud computing. It has rapid elasticity. Now, what we mean by elasticity is like an elastic band. It can stretch to make it bigger, or it can contract to make it smaller. So I don't have to go to someone and say, oh, hey, I want this much cloud computing services. Here's my bill. Next month, they're going to go, well, it's exactly the same month after month after month. No, I can basically expand and contract my requirements as needed. And that's what we mean by rapid elasticity. It gives us resilience and redundancy. Okay, part of that is simply because we're not looking after it ourselves. We hand the responsibility for looking after the resilience and redundancy to the cloud providers. These guys are big dogs who've got big data centers across the world, and it's their job to make sure that our service that we're paying for does what it says on the tin. So it's up to them to basically look after resilience and redundancy to a certain extent. There's a big caveat on that. It's only to a certain extent, and we'll go into a bit more details on that later. And it has beautiful fallover, self-healing, essentially. So many cloud platforms basically have a self-healing capacity, which will automatically recover from hardware and software failures, because we're not looking after the hardware. Someone else is doing it. Well, it's their job to make sure it's up and running. We're paying them a bill. They've got to get it up and running and keep it up and running. So they will basically automatically go around and fix any faults with their particular service without infringing on the capabilities that we have. So we kind of talk about this and what it really means. So let's have a little look at an example. Now, this audio wasn't quite working earlier on, so we might have a little bit of a shuffle around of a few windows here. Okay, thumbs up, please, for everyone if they get the audio.
Excited to be here. My name is Chris Lambert. I'm the Chief Technology Officer with Lyft, and I'd like to tell you a little bit about our journey from being a small, scrappy startup in San Francisco to now being the fastest growing provider of on-demand transportation here in the US. Along the way, I'll highlight how Amazon Web Services has helped us move faster as a company and scale our marketplace more efficiently. I'll start back in 2012. When Lyft launched, it was a really simple service for rides on demand. You could pull out your phone, hit a button, and within a few minutes, a driver would show up and take you anywhere you wanted to go. When we launched, it was just 3 servers, all running in US East in different availability zones. And our very first Lyft ride was completed on May 31st, 2012. And it's funny because the 2 engineers that had built the first prototype weren't really sure how it was going to work in production. Would the state machine work? Would the ride actually happen? So when they were tailing logs, and when they saw the ride drop-off event hit production, they were like, well, maybe it worked. We actually don't know. So they called the driver, and they said, hey, this is Lyft. Did you drop Daryl off? And the driver's like, yeah, I just dropped him off. He's not in the car. And they're like, okay, great, thanks. And I don't know who was more surprised, like the engineers that this worked, or the driver that they're going to get a phone call after every single drop-off asking if they dropped him off. But it was really early on. It was 3 weeks from idea to actual launch. And we were 100% on AWS at the time. The only difference now, we're still 100% on AWS, but we're taking advantage of many more Amazon technologies besides EC2. So fast forward a year, we had our first big milestone as a company, 1 million rides completed. San Francisco was growing like crazy. We had launched Los Angeles and a few other cities, and things were just taking off. You can get an idea of what that growth looks like with just looking at the first 15 months here with our path to 1 million rides. And this has continued for the last 4 years. However, that exponential growth is great, but it didn't prepare us for what was about to happen. We decided to launch 24 additional cities in 24 hours. This was a huge effort across the company: marketing, operations, engineering. And of course, the engineering approach to this problem was, well, let's get out of the way. Let's enable auto-scaling. Let's make it so whatever happens in the real world, whether it's a rainstorm or the Super Bowl, anything that happens, we can handle. Our infrastructure should just scale up seamlessly. So we rolled out auto-scaling just in time for our 24-city launch. Went off without a hitch. We doubled our footprint overnight. And you can just see how significant this is. That last little tick there was all in 24 hours. And that was pretty massive growth for us as a company. And auto-scaling works great for your application tier, but there's one more benefit you get from it, which is that we do 8 times as many rides at peak on a Saturday night as we're doing on a Sunday morning. So auto-scaling also allows us to scale down our infrastructure to save a significant amount on infrastructure costs when we don't need to pay for it. So I mentioned auto-scaling application tier, that's fantastic. But what about data store? One of our biggest data stores was outgrowing its current technology, and we decided to move it to Dynamo. This was the ride location tracking system. So every GPS location for all of our rides was stored in this system. We moved it over to Dynamo, and it was so simple to scale up. You had 2 knobs, one for write capacity, one for read capacity. You didn't have to carry a pager. You didn't have to deal with chunk migrations. It just worked really, really well. And we've since moved many of our other data stores over to Dynamo as well. The single biggest launch in Lyft's history came a few months later. This was Lyft Line. Lyft Line is our shared ride service. What that means is if 2 passengers have a very similar route and they're requesting a ride within a few minutes of each other, we can give them the option to share that ride with the other passenger for a significant savings, often up to 50% off their ride. This changed our business significantly, and it was possible because of some analysis that our data science team did with our Amazon Redshift data warehouse. So we had all of our data in Redshift, and they basically would run simulations every few months looking at what would be possible in terms of new transportation modes. And they realized that 90% of our rides at peak times were co-similar enough to another ride where we could actually build this shared rides product. So as soon as this was the case, we kicked off a few engineering teams, and we were able to launch Lyft Line in August 2014. And it's been the biggest driver of growth in our biggest markets, and is the future of the company. Fast forward a year, we now have a proliferation of many different microservices, all serving production traffic at Lyft, and we wanted a really easy, simple way for them to communicate with each other. And we built this pub subsystem on top of Amazon Kinesis that funnels every single production event through this system. So every time you open the app, every time you request a ride, every time you move, the car actually moves. It goes through this Kinesis pipeline, and any other service at Lyft can subscribe for events. They can say, I care about credit card ad. So our fraud system can say, let me know anytime someone adds a new payment method, removes a payment method, I want to rescore that user's fraud risk. Our dynamic pricing system can say, let me know every time a driver changes neighborhoods, because I want to make sure I'm pricing these rides as accurately as possible. This is a really complex infrastructure with a lot of moving parts, and it's all simple for us because of Kinesis. October 2015 was 3 years after we launched, huge milestone, $1 billion annual run rate. Business is just bigger than it's ever been. To give you a sense of scale, right now there are over 10,000 people in Lyft rides across the country. For them, they're getting to work, seeing friends, seeing family, relying on Lyft for their income. Downtime is not an option for us, and we've been able to depend on AWS to provide the level of reliability and availability that our users have come to expect from Lyft. So I talked a little bit about the services we have in production. On March 2016, we added our 100th microservice. These are all, again, managed independently, scaled automatically, and these services are collectively serving over 1 million requests per second. This is what powers Lyft. Every time you request a ride, you're not just hitting a single service, you're probably hitting 10 or 20 different services that are working together to make that ride go as smooth as possible. And just to give you a little bit of insight, this is the set of Amazon services we're using today in production. These are all taking real traffic. Teams have depended on them, and they've all worked really, really well for us over the last 4 years. So last big announcement, I'm excited to say, as of last month, we completed 14 million rides. Just for context, it took us 15 months to get to our first million, and in the last month, we've done 14 times that alone. It's our biggest month ever by pretty much any metric. We're incredibly excited to be here. We're hiring in San Francisco, in Seattle. Love to have you help come join, build the future of Lyft, and continue to use AWS whenever it makes sense for our business. So thank you for having me.
Wow, so that's a pretty strong message really coming from there. There's a question for the live chat. How many servers do you think Lyft actually use on their own premises? So how many servers do you think they've got in their main office? Alan, smash in. 0. They don't have to, like, remember that big heavy server I showed you earlier on in some of these lectures? Yeah, they don't have to touch that. The whole lot is basically run on the online platform. There's a further discussion question. What were some of the advantages that Lyft basically had when they deployed their application into the cloud? What do you think would have been different if they didn't use the cloud service? That's kind of an open one for the live chat if you want. So what were the advantages they basically had when deploying it to the cloud? Fintech, yes, spot on. Enhanced scalability. They talked about how they could easily go up and down without basically having to really look after things, wasn't it? Cost effective, no space for hardware. Yes, definitely, Seth. Thank you very much. Well, Nell basically backs you up with that one, so it's definitely right. Marty says the cost would have been a lot if they needed to employ a lot of workers. Imagine literally getting to that first stage and going, okay, we've got this beautiful application now, we're ready to run it. How many servers do we need to purchase basically to go live? And someone says, well, we've got to buy 10. The average cost of a HPDL server now is probably about $20,000. And that's a cheap one, let's be honest. So they get 10 of those. Okay, straight away you can say, well, that's $200,000. Do they have $200,000 just to pop like that? With something that may or may not work? So definitely the cost is very important. As I say, there's the difference between the capital expenditure, which is purchasing the whole thing outright, and an operational expenditure, which is purchasing it just while you're using it, which is simply what a lot of the cloud services basically have. Anyone got any questions about what Lyft basically did there? Well, now basically adds another one, accessibility runtime anywhere, yes. Their uptime is maximized with a minimum downtime of hosting. Okay, it sounds like you're reading off of some textbook there, Seth. But yes, exactly right. That's perfect, isn't it? So they maximize their uptime because they're not looking after the thing, someone else is. Andres, safety comes in. Yes, you're protecting user data because it is in a data center looked after securely. Caballero says scale up to 10 to thousands of virtual machines during peak times. Yeah. And who controls that? Do they have to have a guy there monitoring it, going, oh no, we need another one, we need another two, we need another three? Simple answer on that demonstration was no. They simply sit back, put their feet on the desk. As the more and more calls and more basically sales are basically generated, the Amazon Web Service, the auto scaling feature will simply go, okay, we're getting to a certain percentage of our maximum capacity. Let me click on another 2, 3, 4, 5, 10, 20 servers. Up they go. Basically to cope with a ramped up demand for that particular moment. And then when that's peaked off, everyone's got home in bed, they're putting their kettle on, putting their feet on the sofas, and the amount of calls dies because it's gone 2 o'clock in the morning. Well, Amazon Web Services says, we're not going to keep charging you for those 10,000 servers you were running. We're going to scale it right back. We may be using just 10 to 20 servers now. So all of a sudden, your bill that you get from Amazon Web Services is directly related to the money that's actually coming in through the door. So you're not paying for services that you're not using. So it's fantastic. Those are some of the benefits. There's other pitfalls and things, but we won't talk about those yet. So cloud computing. Some user cases, content delivery. Okay, so cloud storage services used for backup data, long-term storage. Yes, you can simply throw stuff into backup data. There's various different formats that you can have, and you will find them coming in different tiers. So if you want instant access to your backup data, then you'll pay a slightly higher amount than if you put it into something such as a cold storage, which is basically a set of data that will be hidden. Hidden is probably the wrong word. It will just take you a long time to get access to it. I mean, we're talking long time in terms of computer terms here, not in terms of going to the Arctic Pole and getting it out of cold storage. Content delivery, as I said, basically we're going to have reduced latency of the web pages and images and videos because a lot of the data centers are based very close to the core of the internet, for want of a better word. So there's less hops for them basically to get that data out to the general public than if you hosted it yourself. Big data and analytics is in there as well. So cloud platforms provide the infrastructure and tools for processing and analyzing large data sets. Okay, that basically makes it easier for organizations to extract the valuable insights from the data. And with Lifty, you said they could basically extract all that information. And because they could extract that information, they could then hook people's rides up. All that data was there. They simply needed some big data analytics to say, are people taking similar rides to the same locations at the same sort of time? And the general answer they said was yes. 90% were roughly that sort of target. So bang, they've got another product on the market now. And then AI and ML. So artificial intelligence and multi-language systems in there, or machine learning rather, I should say. So machine learning basically on cloud platforms. Because we know for AI and machine learning that we need a large amount of processing power. That large amount of processing power is available on the cloud and the web services. So we can tap into that and we can simply use that when we want to do our large amount of chunking for AI and machine learning. And then when we don't need it, we'll turn it off. So it is basically there and we can use it. So let's have a look at a couple of cloud models and resources. So you will tend to buy cloud models in these particular service models. There's a product called infrastructure as a service. Now, it's pretty much as it is. So it is a virtualized computing resources, so provides more control and flexibility of the resources. So you are really only jumping on and looking, or not looking after, you're getting provided the infrastructure. Some people might call this bare metal, but essentially you're simply buying what is known as compute power. So you're buying processor, you're buying a certain amount of memory that you're going to use, and you're buying a certain amount of disk space. Okay, and that's what they're going to provide to you. You can do everything else on top of that, and we'll talk about that model in a minute. Then we have platform as a service. Now, platform as a service is fantastic for developers because as a developer, you don't want to care about the operating system that's installed on it. You just very simply want to go, I want to run my particular application. I don't care what it's running on. I don't care what's happening. I just simply want to do that. So there's a lot less management in terms of how you basically look after things and your responsibility. And then there's software as a service. So software as a service is very simple. That software is simply provided as a service. These are classic ones out there. There are some beautiful ones out there. Microsoft 365 is considered software as a service. So is the Google Workspace. Okay, and so is the majority of your web browsing systems. Okay, these are software as a service. CRMs is one of the popular ones that's basically used over there. Customer relational management databases. There's a product called Bullhorn, which is an early adopter for this. And very simply, it's a software as a service. So we don't have to run the software on our own machine. We simply run it on the cloud. We access it on the cloud. We don't care what device we are accessing it from. We are simply accessing it through a browser. So for a little bit more details then, so infrastructure as a service, you are looking after the infrastructure, or you're not looking after the infrastructure. You're buying the infrastructure. You then install the operating system and the applications on top of that. Netflix is a good example of a company that basically does this. So Netflix uses the virtual compute power from AWS and will very simply run their own applications, and they'll run their own operating systems on the system to provide that particular service for us. So what they're simply buying from AWS is they're buying the physical hardware that basically runs on it. It gives you more control because you have control over the operating system that you're installing. How you configure that is up to you, what you do with it. You get easily scalability because you can simply turn it up and down, similar to most of these things. It's cost effective because you are only paying for the infrastructure as a service. You're not paying for someone to manage the operating system, and you're not paying for anyone to basically configure that for you. It's on demand and it's quickly provisioned because there's virtually nothing to go on it. Then platform as a service. As I said, platform as a service is really good for developers. Okay, it's a slightly managed infrastructure that handles services, databases, and scaling. Okay, it does support auto scaling as well. It's multi-language supports. So multi-language, we're talking about things such as Python, Java, Node, JS. Okay, and certainly a lot more. And there's normally some integrated tools basically offered in there, things such as CI/CD, debugging and monitoring. Okay, so those can be services you can purchase in addition. Most of them basically use some pretty secure services such as SSL and TLS, and include features such as the firewall that's basically on it. So you don't have to worry about all that stuff. You simply go, I'm a developer. All I want to do is build my app. Someone else look after everything else. For Google, that tends to be called the Google App Engine. Okay, is a PaaS service. And then we come to SaaS, like I said, software as a service. So it's an application delivery software over the internet. It requires little or no maintenance for the customer. Once I've released my software as a service application, I don't have to maintain anything. I'm not looking after the hardware. I'm not looking after the operating system. I'm probably not even looking after the application itself. If I'm purchasing into that, such as buying Microsoft 365, I don't care what servers they're running on it. I don't care what operating system they're running on it. All I really care is that I can get to the application and run it. So I'm virtually doing nothing and simply just going, here's some money. This is what I want to use. So say Gmail is basically a similar one as well as the Google Workspace system. It is easily scalable. I mean, how much effort does it take for me basically to add someone to a Microsoft 365 account? It's a couple of clicks. All of a sudden, I've got another service. Okay, all I'm simply doing is agreeing to pay them a bit more money in that software as a service platform. Anyone got any questions about those three main descriptors that we use for the way they basically provide cloud services? Can't see anyone type in there. Okay, that's fantastic. So to kind of give that a bit more visualization, we kind of break it up into pizza. So it's pizza as a service. The old legacy way of doing things is on the left-hand side. You know, we'd have to look after the dining room table, the drinks, the utilities, the pizza dough, the tomato sauce, the topping, and the cheese. So this is basically looking after the whole shebang, isn't it? Whereas with infrastructure as a service, it's a bit like a take and bake service. Someone's done the pizza dough for me. They've done the tomato sauce, they've done the toppings, they've done the cheese. Okay, all I've got to do is bring a dining room table, probably take it home to my dining room table, put some drinks on the side, get some knives and forks, and then basically eat the thing, isn't it? Pass, again, you can see there, we're looking after less and less of the items, aren't we? So we're providing the dining room table and a couple of drinks, and someone's putting a pizza in front of us. Off you go, guys, tuck in. And then software as a service, yeah, we're doing nothing. We're simply sitting down. Someone's probably feeding us, let's be honest. It's that sort of an effect, isn't it? So we look after less and less responsibility. Of course, with less and less responsibility comes a higher sort of a charge. So it's a difference between cooking a pizza at home on your own, doing all the hard work, being really cheap. And when you drop into SaaS, you are literally doing nothing. And someone's bringing it to the door, putting it on the table for you, probably cutting it into slices for you. It's probably stopping short of feeding it to you. But you're going to pay that person a lot more than you are when you basically purchased a pizza straight from the shop and did it yourself, aren't you? Anyone got any questions around those sort of examples? Anyone got any examples? Has anyone used a PaaS or a infrastructure as a service before? No, that's fine. That's okay. I wouldn't expected you to be honest with you. I think all of us will use a SaaS because we're all using either Microsoft 365 or we're using the good old-fashioned Google Workspace, aren't we? Gmail stuff, aren't we? Okay, perfect. So now to break that down even further, because it's not just as simple as that, not just simple as pizza slices and everything like that when we talk about clouds. Companies will have different models of how they deploy these particular services. Now, there's a lot of choice as to where that data actually lives. Okay, so public cloud, we kind of covered, you know, this is really AWS, Azure, Google Clouds, etc. That everything and the virtual computing and the storage and the services are generally available to the public. So anyone can go and go, I want an AWS account. This is where I want to start running my services, and off they go. So that is publicly available. Then you have a private cloud. So private cloud are really infrastructure and resources that are exclusively used by a single organization. Now, they can be hosted by a third party, basically provider. So I can go to a company and simply say, I want you to look after my private cloud. And they'll go, yeah, sure. We've got plenty of racks. We've got plenty of servers. We will allocate you 8 or 9 racks in our database. That is yours. That's just you. Only you can touch that. Only you get access to you. And that is a private cloud. Can anyone think why someone would want a private cloud rather than a public cloud service? I don't think why I might want my stuff really private rather than in the public domain. I mean, public isn't accessible for everyone, but government maybe. Yeah, Marty, thank you very much. So government may be sensitive information. Yes, if I'm running something say, for example, for the health service, or if I'm running something for a government, yes, I don't want to stick that onto essentially a public cloud service. We know that things fall over. We know things that are slightly fallible occasionally. Okay, so we don't want that to be accessible by anyone through any route. We want essentially an air gap between the people out there that access the internet and us. It's ours. It's a private cloud system run for us by a particular company. Alan says data security. Yes, if I'm running one of the security services, I don't want people getting access to that data. Because certainly banking and systems and things like that will basically run on a private cloud service. And then we have what's known as a community cloud. Now, let me take a step. Let me take a step back. Hybrid cloud is where you are basically mixing your public external cloud with your private internal cloud. So a lot of bankings will be doing this because the public end of that is your application that you are basically providing so you can look at your bank details. So I can check my bank details. I go essentially to a public service. All the calculations and all the secret stuff is kept in the private end of that, not in the public end. So I'm running a hybrid cloud. Only through that portal can I get access to my particular data. And then all the rest of what the bank is doing secretly on its own lives in its private connections. And that, when we combine those, it's very simply called a hybrid cloud. And then the fourth one basically on the list is a community cloud. A community cloud is pretty much what it says. It's a bit like a co-op. Community clouds are basically shared by several organizations. I may, for example, run a gardening business. And mine is probably a bad example, but if I run a gardening business, my needs for the internet are probably pretty similar to Joe 3 doors down, who runs a gardening business, or Michael, who lives in Windsor, who runs a gardening business. We might get together and go, hey guys, why don't we have a little chat and work out what we need, and we'll stick this into a community cloud. Okay, so the community cloud tend to be similar industries, similar interests, that have quite often have a balance between some private and public cloud storage. But because they're buying more in bulk, they might get a better discount because they're then getting bigger materials. And they tend to share it between the community. Anyone got any questions about the cloud deployment models that we spoke about there? And of course, we can buy public cloud as infrastructure as a service, platform as a service, or software as a service, just like we can buy our private cloud in exactly the same way. So the big cloud service providers are AWS. Okay, we love AWS. We'll have to say we love AWS, but they're obviously the best. Okay, they are one of the largest, most widely used cloud services providers in the world. Okay, they are really nice. They offer a comprehensive suite of cloud services, including compute, storage, database, machine learning, analytics, and more. And there's the Google Platform Service. Okay, Google Cloud offering also includes a lot like computing, storage, data analytics, machine learning. They're pretty much offering similar items, as well as Microsoft Azure. Okay, Microsoft Azure tended to get preferred by a lot of the bigger businesses because it's Microsoft, and we all love Microsoft in big businesses. But AWS is certainly smashing into that share, and I think they've probably overtaken Microsoft by now. Anyone got any questions about how we basically provide that? Well, we are whipping through this, aren't we? Okay, that's perfect. Right, I'm going to pop on to the next video. Now, this video might fail, and if it does, I will quickly work out why it's failed and we'll carry on. Thumbs up if you get the audio.
Amazon Web Services is an unrivaled colossus of the internet age, providing the computational horsepower underpinning countless organizations. From Netflix to BMW, Disney to GE, Tinder to the CIA. It earns tens of billions of dollars a year. And if you've used the internet at all lately, you've probably used Amazon Web Services without even knowing it. Join us today as we enter the belly of the beast and take a sneak peek inside an AWS data center. In stark contrast to its cardboard boxes, vans, trucks, jet planes and warehouses, Amazon prefers not to brand its vast portfolio of gargantuan data centers. But these monumental server farms are the very guts of the firm's wildly successful AWS, that's Amazon Web Services division. AWS began life at a 2003 meeting in the lake house of CEO Jeff Bezos. The firm had just emerged strong from the dot-com bust, but Bezos' fast-growing retailer was having difficulties setting up and rolling out its own internal server capacity. A scheme promising fast, scalable server infrastructure was duly hashed out, and was swiftly identified, by the more enterprising young guns in the room at least, as a potential spin-off service Amazon could sell on to other companies. Fast forward to today, and AWS rakes in a whopping 60% of all Amazon profits. That's about $50 billion a year. How? By taking on other companies' tech problems in the cloud. If you're a startup in 2021, you no longer need to invest precious capital in vast banks of noisy, expensive servers and battalions of nerds to maintain them. You just rent time on Amazon's gear instead. That's the cloud. When you're busy, yay, you hire more gear. If you're quiet, whatever, you hire less gear. The actual gear in question is jealously hidden from prying eyes by Amazon. Even clients aren't allowed to poke around in the data centers they pay for, and their addresses aren't made public. But here's what we know. Take a typical site in Loudoun County, Northern Virginia. AWS is said to run at least 50 individual data centers in this region alone, covering several million square feet. Believe it or not, Amazon is planning on adding still more capacity in Northern Virginia. For instance, a 100-acre site near Dulles Airport the firm reportedly just shelled out a cool $73 million for. On entry to one such data center, let's say this giant nondescript box next door to a pet resort in Sterling, the first thing we notice is that security is the overriding concern for AWS. There's high fences, guards, and several layers of intrusion detection systems, most obviously cameras. When access is permitted to very limited people for very limited periods, two-factor authorization is required on at least 2 occasions during the visit. If a visit is sanctioned, this is extremely rare, visitors are accompanied at all times by at least one authorized member of AWS staff. Once this so-called perimeter layer is passed, the next stage of the data center is known as the infrastructure layer. This is where crucial systems like backup power, fire suppression, and most importantly, HVAC or air conditioning are situated. To maintain market dominance, AWS data centers cannot be allowed to fail ever for any reason. As such, water, power, telecommunications, and internet links are all designed with full redundancy. And keeping all those servers, as many as 80,000 in a single data center, running requires constant monitoring of ambient temperature and humidity to prevent overheating. If the worst should happen and a fire breaks out, a suite of systems involving water and gaseous sprinkler systems are rigorously maintained and good to go in a crisis. Past the infrastructure layer, and we're finally where the real magic happens, the so-called data layer. Security is even tighter here, with a secretive array of intrusion detection systems and even stricter review process for anybody going in or out. Even if something minor happens, for instance an internal door is held open slightly longer than usual, alarms are triggered. All access points are fortified with multi-factor electronic control devices. If a data breach, physical or virtual, is even so much as suspected, the relevant server is automatically disabled and shut down. These security systems are audited throughout the year according to a robust 2,600-point checklist supervised by external bodies. These external auditors can request access to anything in the data center, from humdrum logs to security footage or even the very cameras themselves. AWS staff are sometimes plucked at random from their shifts and interviewed about topics like the disposal of media, itself a process that's held to exacting and robust compliance metrics. Let's look at the hardware itself. In the midst of all this hypersecurity, it's maybe easy to forget that AWS data centers are fundamentally just enormous banks of servers. A typical AWS data center will hold anywhere from 50,000 to 80,000 servers, running on a combined 25 to 30 megawatts of power. It's said that AWS could quite easily double this size and make even bigger data centers. However, like everything Amazon-related, it's all a question of finely calibrated scale. Distinguished engineer and AWS VP James Hamilton told attendees at the company's reInvent conference in 2016 that beyond a certain point, increasing the number of servers and racks per center no longer lowers the incremental cost. At some point, the value goes down and the costs go up. And in our view, this is around the right number, Hamilton says of the data center size AWS usually goes with. Thrillingly, Hamilton employs the term blast radius to underscore the impact a failure might lead to in a much larger data center, hence the relatively modest dimensions. Still, 80,000 servers is plenty, designed to take in, according to Hamilton, some 102 terabytes of data each and every second. Significantly, the engineer also hinted that the bandwidth within the center is wildly higher even than that. Ever evangelists for vertical integration, Amazon have made great strides in streamlining and perfecting the servers themselves over the years. Unlike other co-location server infrastructure providers, AWS has a much clearer understanding of who will be using its hardware and for what. Removing this requirement to be versatile and generalist has enabled the firm to devise ever more efficient server architectures. When mundane software operations are translated on the hardware or even the very silicon of the chips, this can shave nanoseconds off of processing times. And at Amazon scale, that makes a big difference. Initially, AWS bought servers off the peg, as it were, from traditional suppliers. But steadily over time, the firm began developing its own single-depth servers, exquisitely optimized for airflow in AWS buildings running AWS software. AWS has even developed its own so-called Graviton chipsets since acquiring Israeli firm Annapurna. These Graviton chips, currently in their second generation with a third on the way, use the power-efficient ARM architecture. This represents a break from long-term Amazon partner Intel and its x86 architecture, and is said to give AWS clients 40% better price performance, essentially putting supercomputer-level power in the hands of regular commercial users. In terms of storage, a single standard-sized rack in an AWS center can hold 11 petabytes. That's 1,000,000 gigabytes of data on 1,100 disks. Multiplied, of course, by many thousands of times across many hundreds of data centers all around the world. AWS routers, here comes the science kids, can run custom ASICs or application-specific integrated circuits that support 28 ports with 25 gigabit Ethernet connectivity. This diverges, fun fact fans, from the industry standard 10 gigabit Ethernet and 40 gigabit Ethernet networking speeds, but apparently, according to James Hamilton, offers economies of scale when paired together at 50 gigabit Ethernet. Networking between data centers, essential to provide security and backup for crucial client info, happens over Amazon's own private 100 gigabit Ethernet network, which connects the 25 international regions and 80 so-called availability zones across the vast AWS worldwide network. AWS even lays down its own private undersea cables. But back to our data center. Cooling is an overriding priority, and to minimize environmental impact, AWS, in particular in Loudoun County, Virginia, set out to use as much reclaimed water as possible. This stops the company hogging all the precious local drinking water, which would obviously be a PR nightmare. Loudoun Water, the local utility, are happy to provide this reclaimed water at a competitive rate. AWS pays serious taxes here, but it's worth noting that elsewhere, AWS has installed its own on-site water treatment systems. These prevent pipes clogging up with mineral sediment, which in turn causes costly hassle and delay. And if you think that's crazy, the company has even started developing its own power substations. All those servers use a fair bit of juice, so instead of waiting for slow-moving traditional power companies to develop infrastructure to keep all those all-important racks humming at all costs, AWS simply builds electric substations itself. Day-to-day operations within the data center are described by some ex-technicians as being akin to an ER department for computers. With that much hardware, inevitably things seize up, stop pinging, or require a reboot. Fault finding and upgrading equipment is left to a small army of techs who follow rigorously drilled playbooks that cover almost any conceivable eventuality. Metrics are set by supervisors, encouraging teams to complete tasks quickly and efficiently. Some have complained that the working environment is cold, and it's certainly very loud. In the future, we can expect to see more and even louder AWS data centers come online. From early 2020, a new AWS center opened in the Northern Virginia area alone every 3 months, totaling around 1 million square feet in footprint, and that's just one area. All in all, it's quite the numbers game. What do you think? Do these vast data centers get the credit they deserve for underpinning so much of modern life? Let us know in the comments, and don't forget.
Wow, so that's pretty amazing, isn't it, when you look at those items, look at those numbers. Now, a couple of you basically said that you might have been experiencing some lag. Well, not that you might have. that you were experiencing some lag on the system. So what we're going to do is we're going to I'm going to basically post the video.
The cybersecurity architecture series. In the previous two videos.
In a second. So I'm going to post the video, link to the video that you can watch basically over the break. So has anyone got any questions? I think it's actually amazing that there is so much stuff and so much growth in this particular area. Certainly data centers, as you said, they're opening them left, right, and center. I know up the road here in Slough, we've got another couple opening recently. So they're hunting down people for that particular location. And it certainly is very exciting what they do inside those data centers. But the data centers and how that have attached to cloud, all your cloud apps and all your SaaS and your PaaS and your IaaS are basically cloud services running in data centers. So that's really where the link basically is. So has anyone got any questions they'd like to ask about data centers? Here's a question. Let me ask one for you. Who's ever walked around a data center before? Marty says she hasn't, but she would love to basically walk around one. Alan, you did. Was it exciting? Did they let you into the compute areas? Lucas says, it would be nice to work there, I suppose. Crazy. Alan says it's crazy. They are. I mean, you just look at the image that basically shows you how much stuff is basically put into the racks, the cables going left, right, and center, and understanding all that. It is great fun to work in one of those. Alan got lost. It's easy to get lost. I worked for a company called Ironmark, which was a data center over in Maidenhead. And it did literally take me about 3 weeks to work out where all the different rooms are, where all the different racks were, and which is the quickest way to basically get between different locations. Fantastic fun in there. Anyone got any questions about working in a data center or data centers themselves? I can see Luca typing there happily away. Good. Lucas' question basically there, good question. What extra course we need to get in one? There isn't really an extra course. If I'm honest with you, I used to employ, as I said, I worked at Ironmark before, and we worked at other places. In terms of getting knock staff in and basically getting into the data centers, yes. If you show an aptitude with computers and the ability to follow what they term as playbooks, then yes, potentially you could simply go up there and simply walk in the door and they might accept you. But it's all about experience nowadays. It's all about what you know, and certainly getting a CompTIA A+ exam under your belt is going to demonstrate that. So that will basically get your foot in the door. I believe, and Rasha might tell me off for this, but in that Correlation 1 runs a data center technician course.
Yes, that's correct. We do have a data center technician course, but I'm not sure if it's we have a current USA program, but
Yeah,
I have to get back to you on the upcoming courses for this specific
that's
course.
fine. So I like putting Rasha on the spot every now and again. Okay, so another couple of questions. Career choice, does AWS courses? Okay, that's good. Yeah, that's information for Paul. Thank you very much. I mean, what do we need to learn more? Okay, thanks for both. Okay, Lucas basically had his questions answered. That's great. I see Seth typing. I think what we're going to do is when we kind of run out of questions, just see what Seth's got. We will have a 10-minute break. Those of you who had a bit of lag with the video, I've posted the link for the video so you can watch that when we have a 10-minute break. while you're having your coffee and your pancake or your apple and your banana. And we'll join you all probably in 10 minutes. Let's see what Seth is actually typing there. I wouldn't want to cut him off mid-flight, hey Seth. General question. Can a friend register and just write for a certification in the computer support program? Okay, that's probably not me. That's probably one we'll pick up afterwards. Okay, I think we'll basically pop for a 10-minute break. Look forward to seeing you all in 10 minutes where we will talk about some shared resources and scaling. Well, welcome back, everyone. Well, I hope those of you that were experiencing a little bit of lag earlier on have had a chance basically to catch up on the video. For those of you that did have that, are there any questions that you've brought out now you've watched the video without any lag that you'd like to discuss? See, Rasha has shared a really useful link there that basically deals with the correlation 1 additional training modules that are available. Thank you very much for that. Okay, so let's come back then. A thumbs up for people that can see a shared resources slide. Perfect. Marty, Luca, straight in there. Fastest fingers first. Ronell. Be prepared. I think we will drop into a few Kahoot quizzes in a little while, actually. So be ready for that. I'll give you a chance to load that up when we get there. Precious, Chris, Sanchez, Paul, Khalifa. Might have pronounced that wrong. My apologies if I did. Okay, so one of the major benefits is basically talking about shared resources. And this is why data centers work. Okay, the shared resources is basically a fundamental concept of cloud computing. So rather than me sitting at home or not in my office, for example, in my business, and purchasing one computer that I have multiple processors on with multiple threading in there, so multiple cores in that, with X amount of memory and X amount of disk space. And I will just use that. It'll just be me using it. And I'm not going to be getting 100% function out of that all the time, am I? So just like when we talk about the virtual machines, yes, I'm not going to be making the most out of that individual machine. Cloud services basically work because they can provide a vast array. We can put massive computers in these systems and we can simply share it. So if I'm not using all that resource, well, someone else can use that resource. So effectively, we're getting more out of that individual system. And the same expands for both the networking. So the networking, how often do you use the maximum of your network internet speed? We simply don't, do we? Well, actually, unless we're streaming lots and lots of stuff nowadays, we don't tend to max it out very much. But basically, it means if you share it and share it with lots of other people, yes, well, hold on, that all of a sudden that one gig or that 10 gig line basically is big enough for several people to basically use. And that's the idea with the shared resources. Same with disk space as well. So disk space, I may have 36 terabytes of space on my laptop, on my desktop machine. Well, hold on, I'm never going to use all that. Why don't I share it with other people when I just charge them a little bit of cost? So that's generally how cloud computing functions in terms of the financial end of it. Now, to do that, of course, we have to be able to separate things, and we separate things up with virtual machines or VMs. So a cloud provider will simply come to you and go, what virtual machine do you want? And you will simply say to him, you want a virtual machine with X amount of memory, X amount of disk space, and X amount of processing power. And they'll tick the box, spin it up, and there you go. That is simply infrastructure as a service. Okay, and then that virtual machine may be sat on one box that is being used by 8 or 9 other companies. Not a problem because they're virtual machines, so they're all safe and secure. And of course, you can expand that up and up and up, can't you? Now, of course, that will also bring in additional benefits of the fact that, hold on, if it's in one data center, that can be replicated to a second data center. So if my cloud provider, AWS, has a problem in one data center, say, for example, there's an accidental fire there or something like that, that brings down that data center. Well, if I'm in a group, then, or a zone or region, depending on which company you work for, that will already be replicated to another data site. And therefore, I see no issues with my system because it will simply, the VM will spin up on the other data site, I'll get redirected, bang, off I go. Okay, so it shouldn't affect me because it will simply be fully redundant. And a lot of cloud service providers do offer you regional full redundancy as well as global redundancies. And of course, you have to pay slightly different money for it. But this is all part of the shared. They can do that because they're sharing the resources. So the spare capacity they have in one data center, well, it's spare, so they might as well use it to basically back people's up. That's not quite the attitude to look at it, but that's potentially what goes down that line. So that's databases. Sorry, that's the compute end of things as well with databases. So cloud databases like Amazon RDS, Google Cloud SQL, Azure do an SQL1 database as well, will share the database services, allowing multiple users to basically host their databases on the same physical structure. Now, if you've ever been into a data center and you've looked at essentially what is a NAS, a big NAS system, nearline access systems, they are full racks, and they are full racks of disk drives, loads and loads of disk drives. Okay, and that immense amount can be passed up and handed out to each individual person as a particular allocation. This kind of brings us a bit further onto some of the features that we can basically have within there. There are products such as Docker and Kubernetes, which allow users to share the same underlying infrastructure. And these are basically developing applications, and they're called containers. And they're called containers because within a container, you do not have to have the entire stuff that you put into a virtual machine. A virtual machine, we know, has an operating system. Okay, and then it has our application. What a container basically has is it simply has our application code. And it has the basics that's needed to run on any operating system. So that container is massively portable. It's massively lightweight because I've not got the big chunk of the operating system. Okay, that makes it light, makes it efficient, makes it easily portable. So containers that are basically run on Docker can run on any infrastructure as long as it understands Docker, which makes them light and performance enhancing. And that again is where PaaS basically comes across, which is platform as a service. My developer just wants to write a Docker app. He doesn't care about the operating system below. He doesn't care about the architecture. He just wants to play with his toys. And that is really what PaaS is. And we know when we start spinning off and talking about things like AI, we start talking about the large language models and AI, generative artificial intelligence. With the generative artificial intelligence, we know uses a vast amount of processing power. Okay, we tend to kick a lot of that processing power for artificial intelligence goes onto GPUs. Okay, which is the graphical processing unit, because the processors in those are better at doing the artificial intelligence work than our general CPUs basically has. So anyone got any questions about shared resources? It's basically about sharing the stuff that we have in there. Good. It's all very friendly and very sharey. That's what we like to think. But with the shared resources comes essentially a shared responsibility. We've already spoken about, who's in charge of which particular piece of the pizza. Okay, the funder concept allows us to delegate that responsibility. It's important that when you do go and look at a service provider, that you are 100% aware of which pieces of that pizza you are responsible for. So we know basically if we're doing infrastructure as a service, we are in charge of the operating system. We're in charge of the applications that run on it. So operating configuration, application configuration, and then whatever we fancy doing on top of that, that's all our bag. If a memory chip fails, well, hold on, that's the service provider. It's their job. If a disk drive fails, that's their job. And we know that we then get less and less responsibility the closer we get to our software as a service. So PaaS, we don't care about the operating system. That's not us. We just want to run our Docker system. And that's all we care about, is running our application. And SaaS, yes, that's simply us coming out and grabbing software of someone. Is everyone clear? Can I have a thumbs up for everyone being clear as that as a concept about the shared responsibility effects on infrastructure as a service, platform as a service, and software as a service? Paul Bird's all good. Thank you very much, Paul. Now's the chance to ask any questions, because we have got some time basically to go through things. If you are short of understanding on any of this, very happy to dive in and produce some more details. Ronald, Marty, good. Okay, perfect. So cloud storage and collaboration. We know we use the internet and the cloud basically to store our details. Okay, these services allow organizations basically to store, back up digital files and data that are basically owned by us. Okay, the benefits basically include scalability. If I'm running Microsoft 365, I can simply put more and more and more and more data onto it. It happens exactly the same if you're running a database. If you're running a SQL database using one of their cloud storage systems, yes, I can simply expand my SQL database. It can get bigger and bigger and bigger. And I don't have to worry about going out and purchasing any more disk drives. If it gets over a certain size, yes, they're going to say, okay, you've hit a particular limit, we're going to charge you a bit more money for the next step. Yeah. And again, you simply pay for the services you're using it. So it has a benefit of scalability. It also has a benefit that you can back up that data at a click. We don't have to worry about running around with tape drives if it's in the cloud. I don't have to take an LTO4 tape home every day from my CRM product that I basically backed up every day, because it's done in the cloud. So the cloud will handle backups, and the backup data can go to another geographical location within that same data centers, same data center provider. Those are the words I was looking for. Now, when we talk about storage and types of storage files, there are three main storage options. So object storage, block storage, and file storage. They're all handled slightly differently. Now, I'm going to be strange and I'm going to go from right to left, because this is easier to understand if we go from right to left. File storage. So file storage is the same as we traditionally think about here. Okay, it's the same, you know, full well in our operating system, we have a load of files, don't we? And we put them into different folders and we manage those directories and folders. And it actually appears exactly the same as when we are looking at our directory system. Okay, so this is very familiar to us. We all use this particular system. Block storage. Block storage is very similar to your disk drive. Okay, we've not allocated any file storage onto it. It is a block. It's a mass of disk drive. Okay, so think of it similar to your computer disk drive. It can be structured for data and applications. So again, we write our applications onto our block storage. They're not files, they are files, but they're written as applications. And we basically can write other things. We can write virtual machines onto block storage. We can write certain databases onto block storage. Okay, so that's the big difference between file storage is files, data, and all that sort of stuff. Block storage is where we put our VMs, our virtual machines, any SQL databases, any other particular things we fancy running in terms of that block storage. A couple of examples for block storage are things such as Amazon EBS is an elastic block storage, Google Persistent Disk, and Azure Disk Storage. So something like an S3 storage is a block storage. Am I right there? That might be not object, actually. I might have to check that one later. So object storage. So the difference with object storage is they don't tend to be related to each other. So object storage is very scalable, cost-effective solutions, allows you to store and retrieve vast amounts of unstructured data. Now we talk about data being unstructured. That literally means there's no link. When you use block storage, you're on a particular location. You might have SQL data where things are related to each other. So the items in a SQL database are related to each other. The virtual machine is related to all the data within that virtual machine. So that's pretty related stuff. When we have block storage, we don't care. We don't care that things are related. We are simply dumping files, objects into, for want of a better word, a bucket. Okay, and indeed, they will often be called buckets. As I said, I was incorrect. Amazon S3 is basically a object store, and we used it once basically to put loads of images when we were running a white label dating site. So all the images we simply put into an S3 bucket. They're not related. When I access one image of Peter from Southampton, that isn't related to the image of Sarah from Newcastle. So they're just blocks. So we simply chuck them in. They're not related. They're quite cost effective, can store unstructured data. And again, they're scalable. All this stuff is fairly scalable. Okay, anyone got any questions about the difference between object blocks and file storage? And you'll purchase them differently when you go to each different cloud application. So as I say, Amazon refers to object storage as S3 models. And it refers to block storage as EBS, which is an elastic block storage. And the Amazon file storage is called, strange enough, Amazon Elastic File System. Good stuff. Okay, perfect. So that's the cloud storage types that we have. So we have a little bit of a Google Workspace here. So Google Workspace is an example. Let's have an answer in the live chat. Google Workspace is a type of what service provision from a cloud service provider? Paul Bird, I can see happily typing away. SaaS. Paul's getting a small amount of sweeties straight away, Paul. Yes, it is SaaS. We know it's SaaS because it holds our Gmail, it holds our Google Drive, it holds our Google Docs. Okay, it holds our Sheets, Google Slides, and any calendar thing. How much do I need to worry about where that is stored? You don't. It's pretty much as simple as that. The only real time that you ever get concerned about these things is your geographical location. So what Google and all the other cloud providers will basically do is if I live in the UK, GDPR says my data must be stored within the UK or countries that have similar agreements to us. Okay, it's the same from America. Some American states have slightly different rules and slightly different ideas about what can be stored where. But if I'm a company that's basically storing my data, I can't store my sensitive data, my GDPR data, that is client details and things like that. I can't store them in a South African data center. I'm not allowed to do that legally. So there are legal implications. When you talk about Google Workspace, I signed up for Google Workspace in the UK. Therefore, all my data is stored in the UK data center. Admittedly, there's plenty of UK data centers, but it's stored in that geographical location. Great. Any questions about that so far? I'll tell you what, we haven't managed to pick much questions. Let me get you some questions. So, Kahoot, I'll give you all a couple of seconds, well, a bit of time, basically, to sign up. If you haven't signed up already, there's the link to it. And I'll paste the image as well if you're joining by a phone. Sometimes it's easier on the QR code if you're joining by phone. Good, I can see a couple of you joining, that's fantastic. And Seth, good. I'll give you a couple of seconds for the others to join. Wave your hand if you're having trouble. If you're not, we might well kick it off after my next sip of coffee. Great stuff. Are you ready? Remember, fastest fingers first is Kahoot. The quicker you get the answer, the more points you'll get. Which of these cloud service providers provides dedicated hardware? Oh, split view there. The reason infrastructure as a service is correct and machine as a service isn't is because machine as a service are made up. Infrastructure as a service will normally provide you a dedicated piece of hardware that you're running on. So you know that you've got a certain amount of processor, you know you've got a certain amount of memory, you know you've got a particular network. Software as a service, man, they could be running it on anything. They could be running it on any location, okay, that they're happy with. Platform as a service, very similar to that. So infrastructure as a service, you tend to get dedicated hardware and everything up from that you're responsible to. See who was quickest on that. Marty, thank you very much. You've been asking a few questions today in the live chat, so you've been rewarded suitably there. Precious, well done. Good to see you in the top of the list. Which of these cloud services would Gmail be in? Let's see who's quick on this. We know we're going to have some quick fingers in this competition. Ah, there you go. Gmail. Gmail is very differently a software as a service. So it's a SaaS product. Because I don't care about the operating system. I don't care about the hardware. I'm not interested in terms of the application. I just want to basically use Gmail. So it's a software as a service. Let's see how that actually affects the leaderboard. Marty's smashing it in. Precious is up there. I can see Gambino coming up and Paul B. Well done. Joe, you're coming up as well. Well done. See how we can affect that. Which of these cloud services would Google Apps Engine be in? See how many trip over on this by trying to be fastest fingers. Platform as a service. Google Apps Engine is a platform as a service. Google Apps Engine allows essentially application developers to simply sit there and program their applications. They don't want to know about the operating system. They don't want to know about anything. They just simply want to basically dive in, create their application, and then dive out. So that is a platform as a service. How many of you got tripped up by that one? I know a few of us might be going for fastest fingers first and just smashing one in, see if we get there. Precious basically leaps to the top. Well done. Joe's up there. Marty dropping back a little bit. Max, good to see you in the top 5. 2 more questions. Which of these cloud services would you hold the most responsibility for maintaining? A lot of fast questions, a lot of fast answers there. I like to see. Infrastructure as a service. That's good. So with infrastructure as a service, I'm not looking after the hardware end of it, but I am looking after the operating system. What I install on that is up to me. So I could either run a Linux system, I can run a Windows one. So we can run whatever flavor operating system we want, but we're responsible for that. If there's a bug in it or for security on it, we are responsible for patching. And as such, the application and anything else that we run on it. Good. Let's see how that affects the leaderboard. Paul B leaping up. Well done. And Max jumping up as well, but up 4 places. Well done for the highest climbers there. One more question before we take a break. True or false? When considering my infrastructure, it must be in the cloud or on premises. So must be is important in there. Do I have to choose between the two? False. Got that wrong. Never mind, Paul. Never mind, Paul. You get it next time. False. It's my infrastructure. I can put it anywhere I like. And a lot of companies will go a bit of a mix. They'll go a bit of a hybrid. They'll have essentially they'll have certain servers that they want to keep really tight to themselves. And they want to basically keep it on their own premises. And they'll also want to reach out and have an external amount that they can use for flexible amounts and simply basically doing it. Must was a keyword in there, Cablan. I did stress it, but I think some of you might have gotten a little bit too early. So I can put my infrastructure wherever I like. I can have a hybrid mix of stuff that's in my data center, in my own little location on premises, and I can have some public and some private cloud if I want. So we can basically do it wherever we like. A lot of existing old companies will still have a load of infrastructure. They've still got servers they purchased that they still want to basically run to end of life. So why would they go and basically pay for a cloud service when they've already got the hardware there? Let that hardware get old, let it die, and then throw it up to the cloud and migrate it essentially. So they'll migrate it in chunks. You don't have to do it all at once. You can do a mix and match. Let's see how that basically affects the top four leaderboard. Paul jumping up. Max is on fire. 4-streak answer, Precious there as well. Perfect. Okay, that's the end of the first part of our quiz, and we will have a second part in a short while. So, data centers. We had a little look around the Amazon data center, didn't we? The data centers, we know they're physical structures. We know they are big buildings, okay, and they vary in size depending on who's running them. I've seen tiny data centers. I've seen a data center that's very simply run out of what used to be a warehouse. Someone took over a bit of a warehouse building and went, this is a great place to put data centers. They stuck the racks all on the floor, started building it up, started with one particular location, boxed it all off, and it was as simple as that. And I've seen really complex data centers where you have super security getting into the systems. Okay, so they are a physical structure. They do provide a managed service because it's what we're paying for, isn't it? It gives us some scalability, and it's important for the geographical distribution. There's no point me saying I'm going to run a data center, just as they basically said within Amazon, and putting them all next to each other, because again, that affects the blast radius. If one goes down in that particular area, say there's a electric power outage, or the internet end of things goes down, or someone digs through massive cables, or God forbid, there's something like an airplane crash, yes, it will wipe out that particular area. Okay, so let's have some geographical distribution of the data centers. And remember, it's also important for where our data lives and what we are doing with our data. And one thing we talk about in data centers is you can basically get things such as edge connectors. So although my database may be running in somewhere like Texas, if I'm also providing a similar service to people out in Australia, I might want to key up and twin up some of that data so that anyone in Australia is not having to hop all the way to Texas to get their data, which might be slow in terms of reaction speed. So I can put an edge connector in Australia, and then all my Australian customers are simply going straight to the Australian site. So geographical locations are important. When you look to pick them, there's data security and redundancy. We talked about the type of data centers that they tend to be. So they are graded depending on how good they are. We'll talk a little bit more about security. And cost management is key for data centers. We want to keep them as cheap as possible to make the benefits as big as possible for everyone else. So data center security, it is critical. I don't know how many times I've said during these lectures, you know, looking after our data is key, isn't it? Making sure no one gets access to the wrong data. So it's valuable, it's sensitive information. So we must have robust security. So common security measures are things like access controls, perimeter security, the guy on the front gate with the gates that drop down and don't let you in. So there's things like access controls. File detection and suppression systems. Temperature and humidity controls are very important as well. We need to keep the servers basically running at the right temperature to optimize their performance. We also need to strip out the humidity. Okay, because there's no point blowing wet air through on a server because that might well cling around some colder parts. It also does breed some horrible bacteria in there if it's basically way too damp. We talked about the geographical distribution for data centers. Firewall protections are really important as well. It's all basically building around that security. Regular backups, encryption, it all basically builds on the idea of basically making sure that our data is secure. Access controls we spoke about for business security, didn't we, Ragib? Was that last week? Gosh, it should be fresh in everyone's mind, shouldn't it then? So access controls, so things such as our biometrics, our fingerprints, our retina scans, are all used to gain access into the buildings, physically into the buildings. But also to gain access from remotely into the buildings, we use things like our two-factor authentication and our multi-factor authentications. We may use passkeys, PIN numbers, passwords that aren't password 1234 is important. So we have multi-layers of security, especially to get into a data center. And you know, basically most data centers, to get physical access into those particular buildings, you have to pass through the front security gate where you drive your car through, have a chat, show them your passport and everything. When you park up, you'll then basically walk to reception. Reception will then basically scan you. They'll put you through, you know, one of those airport scanner detectors, metal detectors and things like that. They'll pat you down, search your bags, look for anything that shouldn't be there. So they'll do all that. They'll check your ID, check your site. You're basically due to be signed in. And then you might go through to a guest center where you might be greeted by a knock technician, because you won't be able to wander around that data center on your own. They will always have someone with you. So even though it's your hardware that might be living in that data center, or indeed it may be something else that you're visiting them for, you will always be escorted through that data center so that nothing happens that shouldn't happen. The racks themselves will have a lock on them. They will all be individually locked. And it goes as far as to the extent that every time a server is physically opened, so if you slide a server out the rack and you open the lid, that will actually report to the knock center as an open server incident. So it gets as complicated as that to try and basically get into your systems. I have seen a technician turned away. Bear in mind, this technician worked for this data center for 25 years. I saw him get turned away at security because he failed to bring a form of ID. He failed to bring his passport along. And they literally said, yes, I know who you are, John. I know you've worked here for 25 years. Our policy is if you don't have a form of ID, you're not coming in. And they turned him away. So these are super tight securities in these items. So let's have a look at our racks. I'm not sure how much we've gone into racks before. Our servers tend to be stored in racks. A rack is normally 42, and dyslexia struck me then, 42 U's. Okay, each U is 1.75 inches. Okay, so that's it. So within 42 racks, you can get 42 multiple devices in there. Some of them will be 2 U's, some of them will be 8 U's, some of them will be 16 U's, depending on what you're basically mounting into those items. Okay, so they are different sizes. Normally at the top of our rack, you will see a top of rack switch, a TOR, they're commonly known. And that's basically what links up all the racks in terms of their network connectivity. Down each side of the rack, you'll normally have a PDU, a power distribution unit. So you'll have normally one that goes on the left-hand side and one that goes on the right-hand side. And they will go to different power supplies within the building. And this gives us redundancy. That means for our 2 power units, our systems such as our big HP 360s that have 2 power supplies, we can plug one power supply into the north side and one power supply into the south side. And that means if the south side fails, my system still carries on running. Any questions about the rack itself and what we have in those? We will have things such as our cable management system in there as well, because we hate spaghetti junctions. We should never have a spaghetti junction in a rack because it affects the airflow that basically goes through these. Here's an amazing picture of essentially what is an aisle. We have a hot aisle and we have a cold aisle. No secret to work out. The cold aisle is basically the one at the front of the system. Everyone who's built a PC or done anything like that knows that the cold air comes from the front. All the fans are designed to blow it through the system and out the back. So if you put your hand around the back of your PC, you're going to feel warm air getting blown out. It's the same with basically server systems. The front of it is a cold aisle down this middle section. It's quite often enclosed and basically covered with a canopy, normally a plastic perspex canopy. And you blow the air conditioning system, blows the cold air into the middle, and then the systems blow the cold air through the servers to keep them cool, and out the back is a hot aisle. So when you see people walking around data centers, they will quite often carry a jumper or a jacket that they can open or close. When you walk into a cold aisle, it's cold. Okay, it is designed to be cold. So if you spend any time there, you need a jumper. If as soon as you step outside, you then walk into a hot aisle. And strange enough, it's quite warm because all the hot air is basically been blown out there, and you then want to take your jumper off. Okay, so you quite often see that around data centers. So any questions around that general infrastructure? I've got something up there that basically says rack units, blade servers, NAS and SAN. Who knows what a blade server looks like? Ragib's going to pull up an image of a blade server, aren't you, Ragib? Who's seen a blade server? Hands up if you've seen a blade server. No one, Paul. No, thank you very much for the negative response, Paul. I like that. I thought for a minute then everything had cut off. Just seen it on the internet. Ragib might well post one. So not only do you basically have servers that come as massive systems, such as I basically showed you a while ago, you have systems such as Ragib there. What's that? That's not a HP one, is it? So each one of those devices that you can see sliding in and out of that system is probably, is it 8U? I'm going to guess that that's about 8U. Okay, so that system is, let's stand back a bit to get it. So it's about that high. Okay, it slides in as a big unit. Each one of those is very simply a little caddy like your phone, probably bigger than your phone, that you slide in to the system. Each one of those is a server in its own right. And the benefit of a blade system is each one of those servers doesn't have to have all the fans. It doesn't have to have all the power supplies. So all the power supplies are running out the back of that system. And you simply slide it in and off it goes. Any questions about blade servers? So those blade servers you can see at the front, they've got 3 hard disk drives. There can be different configurations. HP does one that's called a modular system, which I think is a synergy system, which you can actually mount. It's done as a modular system, so you can actually mount disk storage arrays in there as well. So you can have multiple servers and multiple disk storage arrays in the same rack unit. And you kind of pick and choose. You pull one out, stick another one in. And it does the same for the networking, which is basically at the back. They are heavy. You have to have several people to help you mount one of those. But normally you take all the servers out, then you mount it, which is a bit lighter because it's not so much a heavy box. Wow, that's fantastic. Thanks very much, Ragib, for providing that image. It's beautiful. So I did kind of allude to this earlier on. Top of rack switches. Normally there is a switch at the top of the rack. It allows for a central point of connection. What you don't want to have is all your servers basically then having to have a massive cable that then goes to the next connection. You want a short network cable that goes to your top of rack switch that then controls where everything is connected to. Okay, they normally give you rack level connectivity. They're normally pretty swift, give you low latency. They have what's known as a high port density. What that means is for your single U, you will have lots of different connections. So either 42 or something like that in terms of the number of connections. 48 rather. I had to do a bit of maths there. There's normally two of them to give you redundancy. And what they tend to have is you will have a blue and a red cable to give you redundancy that goes to two separate top of rack switches. That means if one fails, you've got the other one that basically works. You simply click across to the next network. So physically, that's how you might end up connecting something like a top of rack switch. So everything basically connects to the top, and then basically everything wires off elsewhere. It reduces your cabling complexity. It shortens the maximum cable length. It means I can re-rack items into this without having to pull cables and work out where cables are going, because it is right in front of me, for want of a better word. And you then have a lower cable requirement, because I can plug, if this one's a 24 port device, I can plug 24 different devices into this, and then have a single, I wouldn't have a single for redundancy, but say, for example, a single cable that then connects all those 24 devices to the rest of my network. Without a top of rack switch, I'd have to run 24 cables through that rack, through the conduits, and out through everywhere else to where they were going. So there's a big benefit for top of rack switches, TORs they call them. Now, they're not always placed on the top of the rack. Some people put them in different locations, but whenever I've been in a data center, I've always made sure they're top of racks. Other important things in data centers, power and cooling. We know full well a vast expense of basically running a data center is going to be the power and the cooling, because they both cost an awful lot of money. So the power must be distribution, redundancy, and monitoring. So they monitor the amount of power that comes into each of those systems. You will find that I talked about the power distribution units that run down the side of the systems. Each one of those, you can have smart ones. So I can monitor the power that each plug is actually taking out of that system to give me details in terms of what server is running hardest, what server is burning the most power, what's most cost effective. And it can also tells me when it fails, which is great. Cooling, in terms of cooling, yes, we can monitor. You will find multiple temperature sensors within both the cold aisle and the hot aisle. So basically either side of the rack. And that is designed to monitor the temperature of the cold air coming in and the temperature of the hot air going out. If there's a big difference, we know it's running, it's working really hard, and it's working quite efficiently because we are pumping cold air in and getting hot air out. If we're blowing cold air in and we're getting cold air out, then something is going wrong. We are not running that system. It could be a gap, there could be some problems. And if the cold aisle itself is warmer than it should be, we know full well we've probably got some systems that might well have been mounted the wrong way around, and indeed they are blowing hot air into the cold aisle. Now, did we do stuff on redundancy? Oh, there's a good question. Redundancy for power units is normally considered to be, our diesel generators and backup generators and things like that. And we talked about N and N+1. So N is actually the number of generators that I would need to run my data center if I lost all power. So if I have a data center that requires 5 diesel generators to produce enough electricity to keep me running, then I have a 5 diesel generator system. Now, if I want more redundancy, what happens if one of those diesel generators fails? Well, hold on, do I cut off some of my systems? So what I have is I have an N+1, which is the number of generators, plus 1 spare, just in case. And we could do N+2 if we're more and more secure. To the extent where some data centers actually run what is called a 2N redundancy, meaning if they wanted 5 diesel generators to run their systems and they'd be happy and all good, they don't have 5, they have 10. Okay, so they double it up. They have twice as many generators, and they're probably different sides of the building to make sure that they can run the system despite any issues, fires, or other damage that happens to the other locations. So that tends to be the power redundancy. So now our air conditioning, our HVAC systems look after the temperature, the humidity. Okay, and they make sure the cooling is basically pumped into the cold aisle for use for the hot aisle. Fire safety, fire suppression systems. Yes, we know full well that we are dealing with lots of electricity. There is potential for fires to happen. Okay, they don't happen very often, but then they do. They're quite quite entertaining. Entertaining is the wrong word. They're a bit devastating for the systems, not over devastating for people, because very few people tend to be walking around the data centers when a fire breaks out. But the systems can be very, very sensitive. Okay, they are designed either to pump some inert gas through the system. We do not use sprinklers where there's electricity involved. So you will not normally find sprinkler systems in there. And they are heavily monitored. So there's a lot of monitoring system that goes in terms of the air quality and the fire safety. Anyone got any questions then before we dive into our next Kahoot session? Okay, that's all pretty good then. Right, quick thumbs up from everyone if you're ready for Kahoot. Paul, Maximilian, good. Let's see if we can change that leaderboard. Ronell, I can't see you on the top of that leaderboard yet, Ronell. I know you can get there. Okay, so let's ready with a question then. True or false? Data centers will only look after physical security. False. Well done, everyone. Pat yourself on the back. Very true. They will also look after the general security. They're in charge of the firewalls. Let's be honest. They're in charge of the data that's coming in. They're in charge of the firewalls, the routing, all that sort of things. They're in charge of. Well done, everyone. Next question. In Iraq, TOR stands for top of rack. Well done, everyone. Okay, so this is the top of rack switches, TORs. Pressure's jumping up a few there. Well done. Multi-select. So pick several answers. In fact, pick 3. Oh, well done. Who picked temperature? Come on, let's have a show of hands if you picked temperature. Power distributions are really, power supplies are really about distribution of power, redundancy, and monitoring. Okay. Temperature, yeah. Okay, we are concerned about temperature, but it's not about the power supply systems. That's basically handled by what we term as our HVAC, air conditioning systems. Okay, so that's what they do. I see Paul typing away there. I won't press the button yet, Paul. Keep typing. Ronald Maximilian. Never mind, hey. Clicking too fast, isn't it? It's clicking too fast. Never mind. We'll get the next one, eh? Didn't affect it massively. Let's see what's next then. True or false? I should be able to find a hot aisle in a data center. True. So hot aisles in the data center is basically where all the air gets blown out into. Definitely. Well done, everyone. So cold air in the front, hot aisle all at the back. All still at the top. Oh, you seem to be smashing this one. Well done. But people are going to catch you soon. Well, they may or may not. True or false? Anyone can book a visit to see a data center. Lot of quick answers there. I just watched that answer value go like that. Good to get a bit competitive at the end, doesn't it? False. No, not anyone can basically book an option to basically go into a data center. Very few people will get access. If it's your own kit, you can actually just take the data center and simply go, you know what, I want to rent 5 or 6 racks and I'll put my own hardware in there. All I want you to do is provide the networking for me. Give me a top of rack switch. I'm going to plug everything into the top of rack switch and off I go. In fact, I can even supply the top of rack switch and I can supply my ISP connection in there as well. So I can do the whole lot and simply rent space. That tends to be like a bare metal consideration. Well done, everyone. Let's see how that affects it. Oh, scale of 1 to 5. I would like to work in a data center. "17 answers. Let's show the answers. Wow, everyone wants to work in a data center. That's smashing. They are great places to work at. Okay, they can be, yeah, okay. Sometimes it can be mundane, but generally it's a springboard. It's a great place to get a lot of experience with servers. It's a great place to work nowadays. Certainly when I started in the data center environment, the NOC staff were, I shouldn't be too rude about them, but they were essentially very geeky. Okay, nowadays it's fun, it's great. There's a lot of progress you can make through data centers. So they are very much enjoyable places to work, I think. You have to get used to shift work, but if you're young, shift work's great fun. So let's see how that basically finishes up the quiz. 3rd place. Precious, well done, Precious. Mardy, 2nd, good stuff. Wow, and who's top? Paul, well done, Paul. You did some great work there, Paul, well done. Max and Cabell basically coming up soon. Well, that was good. Thank you very much for that. There'll be some virtual suites out for Paul and the others. Let me drop back into the presentation then. So we kind of end really with a discussion question. Why do cloud service providers such as AWS go through extensive levels to protect their data centers? Feel free to poke something into the live chat window for me. Cablan says safety. Whose safety? What safety? Let's get more specific, shall we, Cablan? I know, feel confident that you can elaborate on that. That's the words I was looking for. I can see several people typing. Sorry about coughing. Riley says the service they provide, and we need security for our information and data. Yes, security. Paul says massive source of income. Yeah. Any issues will blow their reputation. Yes, you've got to look after it. If you have a breach in your data center, yeah, crikey, it's going to wreck your reputation, and no one's going to want to stick their stuff with you. One defect security breach could lead to a massive loss of trust. Well done, Maximilian. Same as Paul. Cracking stuff. Avoid data theft, Precious. Definitely. Data privacy. Data. How many times have we said data privacy? Yes, it's what it's all about. Fantastic to get so many of those in there. Yes, so they've got to look after your data. You're paying them to look after it, so they better do a good job. Well, that's cracking, isn't it? So to lesson conclusions, we kind of had a look at the characteristics of cloud computing. We talked about IaaS, I wish I'd give a different acronym for that, infrastructure as a service, PaaS, so platform as a service, and SaaS, which is software as a service. We talked about the advantages and disadvantages of cloud computing. Yes, it is very scalable, elastic scalable ability we saw, and we saw with the company that basically did the taxi rides and how they were able to expand things so easily without having to really install all the kit. Imagine trying to install kit to basically expand the amount of numbers of servers they've got. Would have taken them years. Different cloud modules we had a look at, and we had a look at a few user cases for cloud computing. And then we had a quick glance over some data center maintenance and security. So that kind of brings us to the end of the lecture. If you have any questions, yeah, please fire them in. We can happy to chew the fat with you and carry on this conversation.